Hey guys, Miss Judd here. In the last lesson, we talked about Unit 4, writing equations of linear functions, and we talked about how to find the equation of parallel lines. Today, what we're going to talk about is how to find the slope of perpendicular lines. Many of you know that perpendicular means that two lines meet at a 90-degree angle. And so where these two lines meet would be a 90-degree angle. And that is true for this particular graph. But what we'd like to see is how being perpendicular affects the algebraic equation of two lines. So let's look at the equation of each of these lines. So if we look at the equation of our first line, line 1, it is clearly increasing, and we can find its slope by finding two perfect points on the graph. So here's a point here and one here. Its slope is up 5/3. And so we could write its equation in point slope form as y equals 5/3 x, and I'm going to use this point right here in the middle, so plus 3 plus 7. Which, if I distribute through, is y equals 5/3 x plus 5 plus 7, or y equals 5/3 x plus 12. Now let's look at the other equation. We'll call it line 2. For line 2, we have the exact same intersection point, so let's start at that intersection point and work to this other end point. So it looks like it goes down 3, which is a -3, over 5. And so for line 2, our slope would be -3/5, and once again I'm going to write it in point slope form with our point being where they intersect, -3, +7, so x plus 3 plus 7. And if I distribute that through, I get y equals -3/5 x minus 9/5 plus 7, which actually turns out to be plus 26/5. Now, if I look at these two equations, I'm looking for some kind of relationship that I can talk about as to why these might be perpendicular. If I look closely, I notice that the slopes both have a 5 and a 3, but they seem to be flipped, and one seems to be positive and one seems to be negative. And so that is how our perpendicular lines are related. Let's go ahead and write out some very specific vocabulary for this. When we're talking about parallel and perpendicular lines, we're talking about both a geometric definition and an algebraic definition. So for parallel lines, the geometric definition is two lines which never intersect. Whereas for perpendicular lines, the geometric definition is two lines which intersect at a 90-degree angle. And so those are our geometric definitions. That is, if we're looking at a picture, a geometric picture, we would know if those lines are parallel or perpendicular based on these definitions. Now let's look at our algebraic definitions. So in the previous lesson, we learned that parallel lines have the exact same slope. And based on what we saw in the previous example, we noticed that perpendicular lines have slopes in which the fractions are flipped and they have opposite signs. So we actually say that perpendicular lines have opposite reciprocal slopes. And so I want to get a little more specific. The word opposite means different signs, and that means either positive or negative. One's going to be positive and one's going to be negative. Reciprocal means flip the fraction. So let's look at some examples. So our first example says, find the slope of the line perpendicular to the line below. Anytime we see the word perpendicular, we should be thinking opposite reciprocal slope. And so if we want to find opposite reciprocal slopes, what we have to do is find the slope of the line. So let's call this line 1. So I'm using my cursive L1, and let's find the slope of that line. So if I want to find the slope of that line, I need two perfect points. So I like the y-intercept and maybe this point right here. And I'm going to count my rise over run. So the slope of line 1 can be found by doing rise of 2 and run of 1. So our change in y over change in x is positive 2 over positive 1. So that means that our perpendicular line must have a slope that is both opposite and reciprocal. So the slope of line 1 is positive 2 over 1, so our new line is definitely going to have a negative slope. And then the reciprocal part says we should flip the fraction. So the slope of our original line is 2 over 1, which means our perpendicular line is going to be 1 over 2. So the perpendicular line has a slope that is equal to negative 1/2. Okay, let's try another example. Find the slope of the line perpendicular to y equals 3/5 x minus 3. Remember, anytime we see the word perpendicular, we're thinking opposite reciprocal slope. And so the first thing we need to do is find the slope of our line. So if we look at this line here, the slope always comes right in front of the x. So our slope here is 3/5. And so to find the perpendicular slope, we need to find the opposite of 3/5, which is, well, 3/5 is positive, so the opposite is negative, and the reciprocal of 3/5, and so we would change that to be 5/3. So the perpendicular slope would be negative 5/3. Okay, let's try another one. Find the slope of the line perpendicular to 2x plus 6y equals 12. Remember, when we're talking about perpendicular, just like I keep saying, we're looking for opposite reciprocal slope. So we need to find the slope of this line. Since this line is in standard form, we can't just read the slope off the equation. So we need to change this equation into something where we can read the slope. So I'm going to solve this equation for y. So the first thing I'm going to do is subtract 2x from both sides. So I'm going to get 6y equals negative 2x plus 12. And then I'm going to divide both sides by positive 6. And so if I do that, I get y equals, well, negative 2 over 6 is negative 1/3 x, and 12 over 6 is positive 2. So that means that the slope of our original line is negative 1/3. So if I want to find the perpendicular slope, I need to first take the opposite of negative 1/3. So the opposite of a negative is a positive, and then I need to reciprocal it, which means flip the fraction. So it's a positive 3 over 1, which can be simplified to just 3. Okay, last one. Find the slope of the line perpendicular to a line going through negative 1, 2, and 3, negative 5. So just like before, anytime we see the word perpendicular, we should be thinking opposite reciprocal slope. And so then we are going to need to find the slope of the line going through these 2 points. So to do that, we're going to need to think of our slope formula. So remember that slope is equal to y2 minus y1 over x2 minus x1. That is the change in the y's over the change in the x's. So my first point is x1, y1. My second point is x2, y2, and I fill those in. So that would be negative 5 minus 2 over 3 minus negative 1. And negative 5 minus 2 is negative 7 over 3 minus negative 1 is 4. And so then to find the perpendicular slope, I would need to find the opposite reciprocal of negative 7/4. So opposite of negative is a positive, and the reciprocal of 7 over 4 is 4 over 7. So our perpendicular slope would be positive 4 over 7. Please try the few problems at the bottom of your note sheet, and we'll learn how to write equations of perpendicular lines in the next assignment.